In the following video, we're going to examine how to graph absolute value functions. We have to remember when doing this video that absolute value, when you perform the operation, takes whatever is inside the bars and makes it positive. And remember, the smallest value you can have, whenever you take the absolute value of an expression, we learned this expression must be greater than or equal to 0. You cannot have the absolute value come out to be negative after you perform the operation. And the reason why this is helpful is because you first need to, when graphing an absolute value function, you need to identify your starting point. And that starting point is going to represent the vertex of the function. Now, to find the starting point, what you do is you take whatever expression is inside the bars. So that would be here, negative 2x. To find your starting point, you take whatever is inside the bars and set it to be equal to 0. So if I solve this, I get x equals 0. So that means the starting point I'm going to have, or the vertex I'm going to have for this function, is at x equals 0. And so from here, what I do is I create a table of values. And I make my starting point, my vertex, the middle of that table. And so I'm going to put 0 in the middle. I'm going to do two values greater than 0, so 1 and 2, and two values less than 0, which are negative 1 and negative 2. And so if I plug in 0 for this, I have the absolute value of negative 2 times 0. Well, anything times 0 is 0, so I have here the absolute value of 0, which is 0. If I were to plug in 1, I'm going to have negative 2 times 1, which is negative 2, so I have the absolute value of negative 2, which is a positive 2. I can do the absolute value of negative 2 times 2, which gives me negative 4, so I have the absolute value of negative 4, which is a positive 4. I can apply the same idea up here. I can do the absolute value of negative 2 times negative 1, which is a positive 2. So I have the absolute value of a positive 2, which is 2. I can do negative 2 times negative 2 and get a positive 4, so I have the absolute value of 4, which is 4. And I can plot this graph. So at 0, 0, I'm at 1, 2, I'm at 2, 4. I'm also at negative 1, 2, and negative 2, 4. And so remember we looked at this before, absolute value graphs create V shapes. So you start your vertex. I'm going to go through the points on the right. I'm going to start my vertex and go through the points on the left. And so I have here my absolute value function. I found my vertex by setting the expression inside the bar is equal to 0. That gives me my starting point. And from there, I picked a table of values surrounding that vertex, plugged them in, and went from there. So what's interesting here is to kind of check out what we're working with. And we realize we have a line of symmetry that goes through our vertex. So by finding the right half of my y values, I can actually reflect them and get the left half of my values. So let's try this on example number 7. F of x equals the negative of the absolute value. And so I see here, since I have a negative out in front, what that is going to do is that is going to flip my graph. That negative is outside the absolute value, so it's going to stay there, and so it's going to flip my graph, and it's so instead of the V opening upwards, my V is going to be opening downwards. So it's the same idea. In order to start, what you're going to want to do is you're going to want to take whatever is inside the absolute value bars, 1/3 x. You want to take that expression in order to find your starting point, which I said we refer to as the vertex of the absolute value function. you set that equal to 0, and that gives you the x value of the vertex. So 1/3 x equals 0. You would multiply both sides by 3, and you get 0 times 3 is 0. And so my x value of the vertex is 0. So again, I'm going to start my table of values. I'm going to put 0 in the middle. I'll go ahead and do here, I'm going to go by 3s. So I have 3 and 6. I have -3 and -6. Now the reason why is I took a look at my fraction. If I had to plug in, say, 1 or 2, I'm going to get a decimal. But by plugging in a multiple of 3 for x, the denominator and the multiple of 3 are going to make it so I have a nice integer solution, because a multiple of 3 is divisible by 3. And so now I plug everything in. And one thing you need to be careful with here is you want the negative. That negative is outside. The negative of the absolute value. 1/3 times 0, which is 0. So I want the absolute value of 0 is 0. The negative of that is, well, just 0, because 0 cannot be negative, positive, so it's just 0. And now I'm going to go down. I'm going to go plug in 1/3 of 3. And so if I have 1/3 of 3, and I want the negative of it, well, 1/3 of 3 is just 1 times 3 divided by 3, which is 1. So I have the negative of the absolute value of 1. Well, the absolute value of 1 is 1, but I want the negative of that, so this is going to be -1. And so which means that idea of reflection of symmetry we saw, when if I were to plug in -3, I'm also going to get -1. I can do the negative of absolute value of 1/3 of 6. 1/3 of 6, 1 times 6 divided by 3 is 2. So I want the negative of the absolute value of 2. So absolute value of 2 is 2, but I want that number to be negative, so I have -2. And I can reflect it here as well. And so if I were to mark these points, I'm at 0, 0. I am at 3, -1. And I am at 6, -2. And I can reflect these. I'm at -3, -1, and -6, -2. And when you draw them, start at your vertex and work your way towards the outside. And you see your upside down V shaped for this one. So let's try it one last time. Example number 8, f of x equals the absolute value of -x plus 1. So we're going to first do our starting point. We're going to do our vertex, the x value of the vertex. And so I take whatever's inside the absolute value, which is just -x, set it equal to 0. X is 0. And then I'm going to make my table of values. So I'm going to put my 0 in the middle, and I'm going to work my way around, and I'm just going to do 0, -1, -2. I'm going to do my +1 and my +2 down here. And I'm just going to plug them in. And so if I plug in absolute value of -0 plus 1, well, absolute value of 0 is 0, so I'm left with 0 plus 1, which is just 1. And I'm going to plug in the positive. So I have the absolute value of -x, which is a -1 for this, plus 1. Well, the absolute value of -1 is a +1, so I have 1 plus 1, which gives me 2. Which means reflecting it, if I were to plug in -1, I would get 2 as well. So I have the absolute value of -x, so a -2 plus 1, and -2, the absolute value of it is a +2, and 2 plus 1 is 3. And so I could reflect it and get a 3 here as well. And so now we graph, I'm at 0, 1, I'm at -1, 2, I'm at 1, 2, I'm at 2, 3, and -2, 3. And I am to graph these with my V shaped. And so there's the absolute value function. Now, before we leave this video, I want you to take a look at your expressions and go back to see how we did our step functions, the shortcut for it, and see, is there a similar shortcut for absolute value functions? Is there a way to look at this and see what our vertex is, both the x value and the y value for it? Is there a way to look at the function that's going to be given to us and identify how these points are found? And I'm telling you, go look at our shortcut for step functions and then come back in class and let me know if you found a way to use that shortcut with absolute value functions as well.